Okay, hi, welcome to the recap session for energy and work done for the lower sec science syllabus. Okay, the first point that I need to mention in this chapter is that energy is the ability to do work. This is a terminology that you need to memorize, and that the unit down here is joules, okay, by the capital letter J. Okay, in order for work done to be present, there must be two conditions that must be met. First one is that a force must act on any object, and that the force must move in the same direction as the force. Okay, the object must move in the same direction as the force. So what do I mean by that? It's like, for example, let's take the first example. My force is moving to the right. My distance is moving to the right. There is work done because they are both moving in the same direction. But if I'm going to take a look, now this is the part that's different. There's a right angle down here. The force is going upwards. The distance is going to the right. So therefore it's a perpendicular to each other. So therefore there is no work done. In the instant whereby there is no force, like what we said already, there must be two conditions. The first condition down here is not met already. So therefore there is no work done. The next one is that there is a force, but there is no distance. Your second condition that was mentioned down here, that the object moves in the same direction as the force. If there is no distance, there is no work done also. Okay. However, there is one very unique condition that I think most of you may not get it. Is one whereby this angle down here is not a right angle. Okay. The force, there is a portion of the force that's in the same direction as distance, so therefore there is work done, just that it's not a very large value. This is a very rare condition that I don't see much in the lower sec syllabus. Okay, next up we're going to talk about different types of energy. First of all is your kinetic energy. Anything that moves, we will treat it as a kinetic energy. Anything that has movement, anything that has speed. Okay, gravitational potential energy is anything that is higher than the ground, anything that has height. Okay, anything that is higher than the ground or has height has gravitational potential energy. So like, for example, when I'm standing at a roller coaster, when it goes up all the way at the top, I have gravitational potential energy. And when I'm all the way at the bottom, the roller coaster is moving very fast, then it will bring me back to kinetic energy. Okay. Elastic potential energy is one whereby anything that is being stretched or compressed. When you use a rubber band, at time you pull your rubber band and you release it. When you pull your rubber band, at time it's actually elastic potential energy when it's being stretched. An example of when something is being compressed is once when, like, for example, I have a spring, I compress the spring, then it actually stores elastic potential energy. Electrical current is one whereby electrical energy is one whereby there is any form of electrical current. Okay, work done, the formula is work done equal to force times distance moved along the force. So if there is no force, no work done. If there is no distance, no work done. If they are perpendicular to each other, no work done. Okay, they must be in at least some form of same direction. Okay, moving on. Sound energy is any form of vibration. We will hardly talk about this in lower sec syllabus. Heat energy is anything with temperature. Okay, like a fire has heat energy, my body has heat energy and such. Chemical potential energy, the only thing that you need to know as of now is battery. Light energy, I don't think I need to explain much, it's just mainly light. Okay, I know there's another term called wind energy, but actually wind energy is a form of kinetic energy that we will not really use much of that often. Okay, conservation of energy, this is a terminology that you need to remember. There are three conditions. First, the condition is that energy cannot be created or destroyed. Okay, that means it cannot out of nowhere create energy or out of nowhere destroy energy. The second condition is that it can only be converted from one form to another. So it's like, for example, electrical energy convert to light and heat, or for example, gravitational potential energy convert to kinetic energy. Okay, you cannot like make it different lah. Okay, the total amount of energy in the system will remain the same. I'll explain this later in our analogy here. Okay, imagine a swing. Okay, I can't really draw it that nicely, but we know that anything that has height above the ground, this is your gravitational potential energy because there is height. And let's say, for example, there is 10 joules of energy. The third condition down here said that the total amount of energy in the system remains the same. Okay, everywhere in this pendulum down here, it will be 10 joules of energy because they are always the same. So now on to how we convert it. At height down here, the speed is 0. So all the energy down here is gravitational potential energy. At the bottom, the pendulum bob is swinging, is moving. It has only kinetic energy. So during this process of it swinging down, the gravitational potential energy is actually being converted to kinetic energy. So that's a form of energy conversion, which explains that energy can only be transformed from one form to another. So next one down here, kinetic energy is being converted back to gravitational potential energy. This conversion is how energy changes. Oops. Okay. So now we're going to take a look at another example. It's like, for example, a roller coaster that is going to do a loop down here. Okay. So at the start down here, we have 200 joules of energy. And then we also note that because of all the energy in the system remains the same, all this energy at the end also 200 joules. We do not change because energy in the system remains the same. At the height down here, there is only purely gravitational potential energy because there is height, it's not moving. When it's at the bottom, it is moving very fast in this direction. It only has kinetic energy. Okay. Whereas the top down here, right, I have a sphere that is going in this direction, so therefore there is some form of kinetic energy, but because of this height difference, there is also gravitational potential energy. But I just need to take note that 200 joules, 200 joules, 200 joules all remain the same. Okay, so talking about renewable versus non-renewable energy, okay, renewable energy is something that I think all Singaporeans and citizens of the world desire to have. We want to have unlimited amount of energy, but the thing is that we must use it correctly. If you use it wrongly, renewable energy will become non-renewable. Okay, so on to non-renewable energy, it is very limited. We do not have a lot of it on Earth. Okay, and it actually causes a lot of pollution. Okay, non-renewable energy are actually made of fossil fuel. This kind of fossil fuels are because of the decomposition of dead plants and animals millions of years ago, going through high pressure, high temperature to make into petroleum or those crude oil that you see people digging out of oil fields. Okay, for that, right, the examples of such non-renewable energies are like, for example, coal. This one China likes to use it a lot. Gas and petrol. Okay, why is it not good? Is because it actually produces a lot of harmful gases, and there's also a lot of greenhouse gases that are being produced, like for example carbon dioxide, methane gas, carbon monoxide, and actually all these actually lead to global warming, which is why our temperature of the earth is getting hotter and hotter, and that there's also the melting of the polar ice cap and causing the sea level to rise and also causing flooding. Okay, an example of how we use non-renewable energy, which is our fossil fuel, is through the combustion engine. Okay, the fuel contains chemical potential energy. Okay, it is then being burned. Okay, but the proper term is combustion. Okay, I'm burning it with oxygen. It produces heat energy. This heat energy is then used to heat up gases to force it to move, causing the motor to move. So therefore, the energy conversion is just this chemical potential energy converted to heat, converted to kinetic energy. Okay. Now we're going on to the renewable energy. Okay, renewable energy, one example is like, for example, biofuel. Okay, we actually use a lot of sugar cane and water, something that I can't pronounce. We use it to produce ethanol and biofuel. Okay, these are so-called like slightly more environmentally friendly fuel. Okay, all these fuel down here, they contain chemical potential energy, and like similar to that of the combustion engine, the heat is due to the combustion produces hot air that causes it to move at high speed. Therefore, kinetic energy is being the useful byproduct. Okay, but in terms of the negative repercussion, this negative sign out here like that means negative. The negative repercussion of using biofuel is that carbon dioxide can also lead to global warming, and too much usage of it can actually cause it to be non-renewable. Okay, the next one is geothermal energy. Okay, this is something that Singapore don't have. We don't have. Okay, we don't have it in Singapore. Okay, scientists and engineers, right, they actually dig into the earth to reach hot rocks. Okay, why do we want the hot rocks? Is because we want to pump water inside to the rocks, and once the water touches the rocks, it becomes steam. This steam is then being travel back up to the earth's surface to run electric turbines to produce electricity. Okay, so this is how it works. So when I pour my steam, my water into the rocks, heat energy is then being converted to kinetic energy, because steam has very high velocity. Then it causes it to spin the turbine to produce electrical energy. Okay, but however, like I say again, negative harmful effect of using geothermal energy is that there's a lot of poisonous substance like arsenic and hydrogen sulfide, which are actually very poisonous to the human body. It actually also causes a lot of land erosion, because you are digging into the ground. You dig into the ground to just reach the hot rocks, right? The land will be eroded. There'll be like a lot of landslide and such. Okay, and there can also be changes to the patterns of the rainwater, because now I got so many holes in the ground. The rainwater will just seep into the ground through these cracks. Okay, hydroelectrical energy, this is like for example your dams and everything. Okay, what we do is that we create a dam to store a water body behind the dam. Okay, then when the water level is high enough, right, we release them to actually convert it into electrical energy. So right, there are some famous dams in the world, like for example the Hoover Dam and in the US, and the Three Gorges Dam in China. They actually produce electricity on a very mega scale. Okay, so when the water is being stored at a very great height, right, it's actually your gravitational potential energy. Then after that, when it's stored at a very great height, we actually let the water run down the pipes. And when it starts to run down that time, it produces kinetic energy. It converts to kinetic energy. Then the kinetic energy pushes and spins the turbine to produce electrical energy. Okay, one good thing about hydroelectric energy is that there is no pollutants, but there are still some negative side effects to it. Is that when you store water that time, right, it actually cause a lot of flooding behind the dam, and that flooding can affect a lot of wildlife. It can affect a lot of people living around it. So like for example, the Three Gorges Dam in China, what happened is that there was a lot of villagers that had to be displaced because it had been flooded. Okay, another negative effect about this kind of dam, right, is that it does not allow the flow of nutrients and mineral down the river, because it's being blocked by the dam itself. So in terms of the nutrients, right, a lot of nutrients will be stuck before the dam. After the dam, right, all those animals down there will get lesser and lesser nutrients. Okay, next up, solar energy. Okay, solar energy is something that I think a lot of students down here know. Is that we convert light energy into electrical energy via photovoltaic and solar cells. Okay, these are the things that converts it into electrical energy, which is what we want. Okay, light energy converted into electrical energy. One good thing about solar energy is that there is no harmful substances that is being produced. However, for the negative side effect is that if there is too much cloud cover or too little sun, right, that means like a very cloudy day, then it's very gloomy day, the efficiency of solar cells will not be ideal, because light is being blocked by the clouds. Okay, the last type of energy is wind energy. Okay, Singapore also don't really have much of this. Okay, we actually, what they do, right, is to convert the energy of moving wind. The keyword down here is moving. Moving means kinetic energy, okay, into electrical energy by spinning turbines. Okay, so we convert kinetic energy into electrical energy. One good thing about this, right, is that you are able to use it at very remote areas. We do not need a lot of infrastructure. It's quite easily done. So one country that is very famous for using energy is the Netherlands, because they have a lot of big empty space that is very high winds that are being passed by. So therefore, they use it to turn the turbines. So one thing that is negative about this is that actually this kind of spinning blades, right, it kills a lot of birds, and also because it is very noisy. Okay, so I think this is the end of this topic for the lower sec science on energy and work done. Okay, please find your teachers if you need any additional assistance.